So let's work on some problems that involve proportions and triangles. Let's start with this one. Triangle ABC is similar to triangle DBE. What is the value of x in the figure shown below? Now for each of these problems, I recommend that you pause the video and try it yourself. So let's draw the two triangles, the small triangle and the large triangle. So the small triangle is the one we see on top. So that's triangle DBE. And then the large triangle is this whole thing. And that's triangle ABC. So we're told that these two triangles are similar to each other. So as a result, we can write a proportion between their corresponding sides. So notice that AB corresponds to DB. So we could say that AB over BD, that has to equal the ratio of the other two sides, BC to BE. So anytime two triangles are similar, their corresponding sides have the same ratio. So in this example, we see that DB is 8 and AB is 12 plus 8, which is 20. Now BE is 6 and BC is the sum of 6 plus x. So let's calculate the value of x. So AB is 20 and BD is 8. BC is 6 plus x and BE is 6. So let's cross multiply. 20 times 6 is 120. And then 8 times 6 plus x, we need to distribute. 8 times 6 is 48. And 8 times x is 8x. So we need to subtract both sides by 48. So these two will cancel. And 120 minus 48 is 72. So 72 is equal to 8x. So now we need to divide both sides by 8. So 72 divided by 8 is 9. And so that's the answer. X is equal to 9 in this example. Now we could check the work. If we take 12 and divide it by 8, that will give you 1.5. So if you take 8 and multiply it by 1.5, you can get the other side 12. Now if you take 6 and multiply it by 1.5, it will give you x. So 6 times 1.5 will give you 9. So that's a quick way in which you can get the answer, because those sides will be proportional. Number 2, DE is parallel to AC. If DE is parallel to AC, what is the value of y in the figure shown below? Now we could use something called the side splitter theorem. So what exactly is the side splitter theorem? What do you think it is? Well, this theorem states that if a line is parallel to one side of a triangle, so we can see that DE is parallel to AC, so AC is one side of the triangle, and intersects the other two sides, so this line DE intersects sides AB and BC, those are the other two sides, and this one was the first side. It divides those two sides proportionally. So these are the three sides of triangle ABC. DE is parallel to one side and it intersects the other two sides. So therefore, these two sides has to be proportional to those two. So we have this expression. BD divided by AD is equal to BE over EC. Now BD is 15, AD is 24, BE is y, and EC is 30. So now we can calculate the value of y. So 24 times y is equal to 15 times 30, which is 450. So to calculate the value of y, we need to divide both sides by 24. So 450 divided by 24, that's a fraction. But as a decimal, it comes out to be 18.75. But now let's get the exact answer. So let's reduce the fraction. 450, we know it's 15 times 30. And 24, we could break that into 6 times 4. Now 30 is 6 times 5. And so notice that we could cancel a 6. And 15 times 5 is 75. So y, the exact answer, is 75 over 4, which is still 18.75. Both answers are exact. So that's how you can use the side splitter theorem to calculate the value of y. Now, because these two lines are parallel, the corresponding angles are congruent. So these two angles are congruent to each other, and those two angles are congruent. So we have similar triangles. So therefore, we can use the method that we used in the last example to get the same answer. So let's draw two similar triangles, the small one and the large one. So the large one is going to be triangle ABC, and the small one is triangle DBE. So we can see that DB is 15 and BE is y. AB is 15 plus 24, which is 39, and BC is y plus 30. So let's set up a proportion. So the ratio of these two sides, that's BC to BE, is going to equal the ratio of these two sides, which is AB to BD. BC is y plus 30. BE is y, AB is 39, and BD is 15. Now let's cross multiply. So this is going to be 39y, and that's equal to 15 times y plus 30. So if we distribute, that's going to be 15y, and 30 times 15 is 450. So if we subtract both sides by 15y, 39y minus 15y, that's 24y, and that's equal to 450. And this will give us the same answer, because we saw that 450 over 24 reduces to this, or 18.75. And so both techniques will give you the same answer. But in this example, the side splitter theorem was a lot easier than using the triangle similarity method. Number 3. Using the figure below, what is the sum of x and y? So first, we could see that DE and BC are parallel. Because they're parallel, we can use the side splitter theorem for these sides. So we could say that AE divided by EC is equal to AD divided by DB. So AE is 24, EC is 32, AD is 6x minus 3, and DB is x squared minus 4. So let's cross multiply. So 32 times 6x, that's going to be 192x. And then 32 times negative 3, that's negative 96. And then 24 times x squared is 24x squared. And 24 times negative 4 is negative 96. So now, let's add 96 to both sides. So both of these will cancel. And so we'll have 192x is equal to 24x squared. And I'm going to take this and move it to the other side so that we can factor. So we can get two answers for x as opposed to one answer for x. Using the figure below, what is the sum of x and y? So notice that DE is parallel to BC. So based on that, we can use the side splitter theorem for these sides. So that can help us to calculate the value of x. So first, let's write an equation. So AE divided by EC has to equal AD divided by DB. So the ratio of these two sides has to equal the ratio of those two sides. In this example, AE is 24, EC is 32, AD is 6x minus 3, and DB is x squared minus 4. So let's cross multiply. So let's multiply 32 by 6x minus 3. 32 times 6x is 192x. And 32 times negative 3, that's negative 96. 24 times x squared is 24x squared. And 24 times negative 4 is negative 96. So let's add 96 to both sides. So notice that these two will cancel. And so 192x is equal to 24x squared. Now, in order to get two values of x as opposed to one value, we need to take this term and move it to the other side and factor. If we do so, we're going to have 0 is equal to 24x squared minus 192x. So now let's take out the GCF, the greatest common factor, and it's 24x. 24x squared divided by 24x is x, and negative 192x divided by 24x, that's going to be 8. So we can set each factor equal to 0. So if we set 24x equal to 0, x is 0. You need to divide both sides by 24. And if we set x minus 8 equal to 0, x is 8. Now, should we include both answers or just one of the two answers? If we plug in x into 6x minus 3, it's going to give us negative 3. And we can't have a negative side length, so we don't need this answer. So therefore, the right answer is x is equal to 8. So now we need to calculate the value of y. So we need to focus on these two sides. So we're going to use the triangle Similarity Theorem to get the answer for that part. Now before we work on the other part of the problem, I want to mention something. You cannot use the side splitter theorem for the parallel lines. You could use it for the segments that intersect the parallel lines, like these. You could use the side splitter theorem and triangle similarity method to calculate the value of x. But the segments that are parallel to each other, these lines here, you cannot use them. You can't use the side splitter theorem for that. You have to use the triangle similarity method. So just want to mention that. So now let's draw two similar triangles. So this is going to be triangle ADE, and here we have triangle ABC. So DE is 4y plus 10. AE is 24. AC is the sum of 24 and 32, so that's 56. And BC is 14y. So let's write a relationship between these two. Now for those of you who might be confused with this step, here's what you can do. On one side of the fraction, write L, and S for the other side. L is for the long side, S is for the short side. Now for the numerator, put triangle 1, and for the denominator, put triangle 2. So let's call this triangle 1, and this one triangle 2. So for triangle 1, the long side is 24, or rather AE. I'm just going to write the equation first. The short side is DE for triangle 1, so that belongs here. Now for triangle 2, the long side is AC. And for triangle 2, the short side is BC. So that can help you to set up the right equation so you can get the right answer. Now let's plug in what we know. So AE is 24 and AC is 56. DE is 4y plus 10 and BC is 14y. So let's get rid of this and let's cross multiply. So 24 times 14y, that's going to be 336y. And then 56 times 4y is 224y. And then 56 times 10 is 560. So let's subtract both sides by 224y. So 336 minus 224, that's 112. And now we need to divide both sides by 112. So 560 divided by 112 is 5. So now our goal is to calculate the sum of x and y. So x plus y is going to be 8 plus 5, which is 13. So this is the final answer to the problem. The sum is 13. Number 4. What is the value of x? Now let's call this L1, L2, and L3. So notice that L1, L2, and L3, they're parallel to each other. And let's call this transversal 1 and transversal 2. So whenever you have 3 or more parallel lines that are intersected by 2 transversals, the parallel lines divide the transversals proportionally. So the segments on the left have the same ratio as the segments on the right. So we can write an equation. The ratio between AC and CE is equal to the ratio between BD and DF. So AC in this example is 12, CE is 30. BD is 18, DF is x. So let's cross multiply to calculate x. So this is going to be 12x, and that's equal to 30 times 18. So 30 times 18 is 540. And now let's divide both sides by 12. 540 divided by 12 is 45. And so that's the value of x in this problem. Number 5. What is the value of segment DF if BH is equal to 65? So in this example, we have 4 parallel lines cut by 2 transversals. So BH is 65, so it's this value here. And our goal is to calculate DF. So how can we do so? It's important to understand that the ratio of the segments on the left side is equal to the ratio of the segments on the right side. So that means that the ratio between AC, CE, and EG is the same as the ratio between BD, DF, and FH. So the ratio between AC, CE, and EG is just these numbers right here. It's 6 to 8 to 12. And so that's going to be the ratio between BD, DF, and FH, which we could say it's 6x to 8x to 12x, where x is currently some unknown variable. So I'm going to say this is 6x, 8x, and 12x. So now, if we can calculate the value of x, we could find the length of segment DF. So what we need to do is set the sum of these 3 values to 65. So 65 is equal to 6x plus 8x plus 12x. 6 plus 8 is 14, and 14 plus 12 is 26. So now let's divide both sides by 26. 65 divided by 26 is 2.5. So this is the value of x. So now we can calculate the length of segment DF. So DF is equal to 8x. So that's going to be 8 times 2.5. So 8 times 2.5 is 20. So DF is 20 units long. So this is the answer to the question. Now, if we wish to calculate BD, it's going to be 6 times 2.5, which is 15. And FH is 12 times 2.5, which is 30. So notice that these three values add up to 65. 30 plus 20 is 50. 50 plus 15 is 65. But this is the answer that we're looking for. What is the value of x in the figure shown below? So how can we find it? We need to use something called the angle bisector theorem for triangles. And the basic idea behind this theorem is that if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. So these are the opposite sides, and you could describe this as the adjacent side. And this is the ray that bisects the angle. So if we call this angle 1 and angle 2, angle 1 is congruent to angle 2. So ray BD, we could say that it bisects angle ABC into two congruent parts. And so whenever we have that, whenever these two angles are congruent, then the ratio between the opposite sides of the two triangles and the adjacent sides of the two triangles will be the same. So to set up this ratio, this can help you. On the top, I'm going to put the information for triangle 1, and on the bottom, triangle 2, which is associated with angle 2. Now the ratio of the opposite sides will be equal to the ratio of the adjacent sides for these two triangles. So opposite for triangle 1 is this side, so that's AD, and opposite for triangle 2 is this side, which is DC, or you can call it CD if you want. Now the adjacent side of triangle 1 is AB, and the adjacent side for triangle 2 is BC. So that's how you can set up the proportion. Now AD is X, DC is 16, AB is 12, and BC is 20. So let's cross multiply. This is going to be 20x, and that's equal to 16 times 12, which is 192. So now what we need to do is divide both sides by 20. So 192 divided by 20 is, as a decimal, 9.6. Now if you want to get an exact answer, let's simplify it. If you want to get like a simplified fraction, 9.6 is an exact answer. So we said 20x was equal to 16 times 12. So x is 16 times 12 divided by 20. Now 20, I can break that up into 4 and 5. 16, I can break that up in 4 times 4. So notice that I can cancel a 4, and that's about it. 5 doesn't go nicely into 12. So 4 times 12 is 48. So you can leave the answer as a simplified fraction. It's 48 over 5, or 9.6. So that's the value of x.